Hello dear students, I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. Today I'll go to discuss about the system that is Hall Container System. In this whole lecture of this integrated solid waste management, today we'll discuss about the secondary collection method, and in secondary collection method I have already discussed Hall Container System is either in a conventional mode or in a stationary mode. So today we'll start this Hall Container System and we'll solve some problem statement on this Hall Container System, like which is feasible, which we should adapt, which is economical, and how we can calculate the waste percentage, and how we can calculate that how much vehicles we need in a 8 hour of total operation. So let's start this lecture with just the basics of this Hall Container System. First of all, this Hall Container System is used for the storage of waste and are hauled to the processing or transfer or disposal site empty and returned back to the either their original location or some other location. So that is mean by a Hall Container System. What happened in this Hall Container System? Vehicle will go and vehicle will drop the waste to the facility, either MRF facility, material recovery facility, or landfill site, or whatever it is there. The vehicle will go and deposit that waste to this processing unit, and then come back to either its original location, and then the vehicle will go to the next location. In this way, this collection has been done in the municipality. A vehicle will hauled with the dustbins, and they will deposit the dustbin to the location site, and again it will hauled and it will go back to the either next location, or again it will start its collection time. Like this, a stationary container system is also there. Stationary container system means just a little difference between with both of this type of system is like that the containers used in this system is for storage of waste. It will remains at a point of waste generation except when moved for the collection. Because what happened, I have already discussed this Hall Container System whole operation. Like a vehicle will come and the vehicle will take that container with it, or they installed again the empty container. But in this stationary container system means vehicle will come with an empty vehicle will take the waste only, and the container will be a stationary, means it is fixed at a place. This container is fixed in the large location site, or wherever the location is there for this waste collection system. This container has been stationary, it will not move, means container will not move. But Hall Container System is generally two type. Like first one is the conventional method. In conventional method, what they will do, they will take the container to the MRF site or landfill site, and they will again bring back the empty container to that place. This is the meaning of this Hall Container System. But this Hall Container System is like stationary. Sometimes it should be stationary. In this way, what happened? The cost, the time that has been involved while taking one container to the empty to the material recovery site, and then taking back the container to again the particular location, will take more time. But in the stationary collection system, what they will do, they will collect the waste into their vehicle, and then they will go to the next location. In like this, hauling will be done, and for next location to again the next location, in which the time for coming and depositing the material, the waste to the landfill site or to the material recovery facility will be reduced. So this will be a better, that is stationary container system. Now comes to the next point, the benefits and the different features of this Hall Container System. So this Hall Container System is basically suited for the removal of waste from sources where the rate of generation is high. Means like for a metropolitan city, where a place where the waste of generation is very high, so that place is suitable for this Hall Container System. And the use of large container eliminates time, as well as the unsightly accumulation and unsanitary condition associated with the use of numerous small container. As what happened during the collection of waste, if you will use numerous container system, like if numerous vehicles is there, then more vehicles is there, and that vehicles is not properly mechanized vehicle also. So while taking the waste, this will create some unsanitary condition, or sometimes waste spillage is there. sometimes nuisance will create it, so that this condition is not much environmentally friendly. And hall container system is environment friendly because of the reason, because at one time it will take more waste. First thing is that. Second thing is that the vehicles is itself a mechanized vehicle, like vehicle will take the garbage and take it and dispose it to the landfill site. In this way, no much labors or person is involved while handling of the waste. So in this way we can say that this whole container system is a good container system, and it is a very much beneficial, and it is a good for the metropolitan cities, or the place where the waste generation is very high, or where the waste is generated in a more amount. So another advantage of this hall container system is a flexibility. Means what type of flexibility? Like containers of many different size and shape are available for the collection of all type of vehicles. Means every different size and shapes of the vehicles are available for the collection of the waste. So this is a flexibility also while collecting the waste, because sometimes what happen, if a big vehicle is there, or that if that route of the vehicles while going through a very busy area, while going through a high traffic area, so in this way that route, the vehicle will go past through a high density population area, or with a marketplace, or with a high traffic condition. In this way this will create nuisance to that particular place also. So that the this type of hall container system is good, too much good for the place where most waste generation is there, for the place where more amount of waste is generated, and this will take, at one time it will take more and more amount of waste. So this is the benefits related with this hall container system. Now comes to the next point, how this process has take place, how this hall container system will be doing. So what happened, an empty storage box, that is known as drop off box. One empty storage is there and one full container is there. So what happened during the whole process? First of all, you can see in the picture, this is the beginning or dispatch of the route. So this is the beginning of the route. So that what they will do, they will take this filled container, means occupied container, to the transfer station, like either the landfill or MRF site, material recovering facility site, and then the vehicle hauled it into the big place, and the vehicle will take the empty container to that location again. In this way they will go to the next location, then they will do pick up loaded container, and they will again put empty container, deposit empty container, like this they are doing. So this is the conventional mode of haul container system. Like this it is doing from many times. So the container is hauled to disposal site, empty, and returned to the original location or some other location. Container has installed to the loaded container has been empty at the MRF site or transfer location, and then returned to its original location or some other location. Like this will be done the whole day in 8 hours of duration. They will go to the next location. Like this whole container system is working. Now comes to the next point, that is about the what are the operations has been involved in this conventional type of hall container system. So first is the pickup of the waste. Pickup means pickup of waste. Like what is doing there, the container has been taken by the person, and the beginning of the daily route is there, beginning is there, and the time that is involved while collecting the waste from a occupied container and giving from an occupied container. So this will involve a pickup. This is only a pickup. And now next point is the haul, means this too is called as haul timing is this too, means like taking the container to the MRF site and then returning back that empty container is called as haul. This you can see that this is the haul, means the whole operation involved while taking the filled container and depositing again the occupied empty container is the whole timing is there. This is called as the haul. Next is the at site, means what time has been spent here only. Like at the final recovery station, final waste disposal location, the time involved while while waiting or while going through that place is called as at site, and off route is the timing, like operation involved depositing the waste to the waste disposal site. So there are four operation involved in this haul container system. First is the pickup, haul, at site, off route. So these four will make one operation complete, like picking up the waste and then hauling the waste, and then at site weight or at site what time has been involved, and then again off route by the vehicle. So these four are the mainly operation that has been involved during the haul container system. Now comes to the next point. This is the first one I have discussed is like the conventional mode. Now I am going to discuss exchange container mode. Exchange container mode operation sequence. What happened? This is the beginning of daily route. Daily route, they will deposit one empty container and they will take the filled container and they will go to the next MRF site, hauling it to the MRF site. This is the whole operation. Again, deposit the empty container from previous location and pick up the loaded container and depositing it, hauling it to the original location or the material recovery site. So this haul loaded container from location 1, then location 1 to 2. This type of situation is a exchange mode container. So in next classes, next lecture, I'll discuss problem statement on both type of this haul container system, either exchange mode or conventional mode. So we will get idea which one is better, which one is economically viable, which we should adapt. So this is exchange container type, and that one that I have discussed is the conventional mode of conventional haul container system. Now analysis, we'll do the analysis, we'll do one problem statement, we'll solve one problem statement of related with this haul container system. So first thing is that what we have to imagine, we have to calculate solid waste from a new industrial park is to be collected on a large container, and some of which will be used in conjugation with the stationary compactor. So solid waste will be collected from a large generation site, that is a industrial park, and based on the traffic studies at similar parks, it is estimated that the average time to drive from the garage to the first container, that is location, that is T1, and from the last container location to the garage each day will be 15 to 20 minutes respectively. First reaching the first site will take 15 minutes, and then reaching the last container site is taking the 20 minutes. So this is the condition. So if the average time required to drive between containers in 6 minutes and one way distance to disposal site is 15.5 meter, like 25 kilometer, and speed limit is 88 kilometer per hour. So determine the number of containers that can be empty per day based on the 8 hours work day. So this is the condition. We have to solve this problem statement, like solid waste collection should be done from a new industrial park where the first container will be come at the location, that is T1, within the 15 minutes, and to the by reaching that location to the garage each day will be 20 minutes. So if the average time required to drive between two containers is 6 minutes and one way distance to disposal is 25 kilometer, then a number in a whole day, how much container they can be empty per day, and the work day is the duration of the whole working day is 8 hours. So we have to calculate this by the average time required to drive between containers in 6 minutes and one way distance to disposal site is 15 minutes, that is 25 kilometer and 88.5 kilometer per hour. So determine the number of containers that can be empty per day based on an 8 hours work day. So now solve this equation by this method, like as we have already discussed that PHC is equal to PC plus UC DBC. PC means time taken while depositing the occupied container, and UC is the time taken while depositing the empty container, and DBC is the whole time taken. So P is equal to hauling time, P is equal to haul time. So using PC plus UC is equal to 0.4 hour per trip. It is given as 0.4 hour per trip. So the DBC will be DBC is equal to 0.1 hour per trip and it is already given. So the pickup in the hauling of the whole container system is equal to zero point 0.4 plus 0.1 is equal to 0.5 hours per trip. Means it will take half an hour in a trip. And now comes to the second part. First, we'll calculate the pickup time only. As I have already said that 4 operation is involved. First is the pickup. So 0.4 hours per trip means while picking up the waste, half an hour will be taken in all the trip. And next statement is about like the determine the time per trip. So we have to calculate the total time involved during the for the per trip. So THCS is equal to PHCS plus S plus A plus BX. So S is already given like 0.133 hours per trip. Okay. Then A is equal to 0.0166. B is equal to 0.011. So this has been already given. So for calculating the THCS, like time taken for hauling one container, THCS is equal to 0.5 plus 0.133 plus 0.016 plus 0.011 into 50 hours per trip. So is equal to 1.20 hours per trip. So this is the time that has been taken by the per trip, like 1.02 hours per trip. And now comes to the next part of this numerical, that is the determine the number of trip that can be made per day. So in a single day, in a 8 hours, how much trip they can make. So that has been the main question. So as we have already calculated the pickup timing and haul container haul timing, like in a pickup half an hour is given, and in the hauling 1.5 hour is taking. So it will be calculated by this formula, ND is equal to 1 minus W H minus T1 plus T2 and divided by PHCS plus S plus A plus B. This has been already calculated. So like this, if we'll put on the whole formula, ND is equal to 1 minus 0.15, because this is a half an hour, this is the pickup timing, into 8, because 8 hour is the total operational time. Next is a 0.25 plus 0.33 divided by 1.20 hours per trip. So is equal to 6.8 minus 0.58 divided by 1.20. So is equal to 5.18 trips per day. So this is about the whole trip we have calculated. So in a 8 hours of duration, the whole trip will be 5.1%. So 5.18. So actually 5 trips per day. So 5 trips per day. So if on the basis of this one only, we have to calculate how much the actual timing is involved in a single work day. So to determine the actual length of the work day is equal to 5 trips. 5 trips, as we have already calculated, is equal to 1 minus 0.15. 1 minus 0.15 hours minus 0.58 divided by 1.2. So H is equal to 7.74 hours. So rounding off, it is 8 hours. So already it is created. So in a single operation of a haul container system, it will take 5 trips per day in a 8 hours of duration, and the pickup timing will be half an hour. then it can be take 5 trips per day, and then the time involved in here is the 8 hours per day. So this is the problem statement that has been involved with this hall container system. Now comes to the next different type of consequences, different type of things that is involved, that is associated with this type of hall container system. So the frequency of waste collection by external stakeholders greatly influence the waste collection cost and depends on a number of factors. So these factors are like quantity of waste, means what quantity the waste is generating, means how much amount to the waste is there. If waste is in more amount, either it is the waste is from public area, from a park area, or either from an industrial area, so this will be a very important factor while considering all type of container systems. Next point is the rate of generation, means how much the rate of generation of the waste. Sometimes some days more waste are generating, some days no waste are generating. Like this, if an educational institute is there, then 5 days more waste are generating, one day Saturday Sunday no waste is generating. So the rate of generation is also a very important factor while considering hall container system, because hall container system will do, either it will work daily or it has to be work on the alternate days. So all these factors will determine, will take deciding how this hall container system will work. Next is the characteristics of the waste. Characteristics means which type of waste is there, like it is a organic waste, it is biodegradable waste, or non-biodegradable waste, or it is a municipal solid waste. Which type of waste is determining from that particular place. Next point is the climate. What are the climate of that particular area? Climate means the average weather condition, which type of weather condition is there in that place. And density and type of housing. Density will means how much dense is that place, how much population are living at that particular place, and which type of housing is there. Either it is having a big apartments or having a normal story dwelling, normal 0 to 4 type of floors, or 4 to 8 type of floors, or more than 8 type of floors. So depending on all these factors, the whole container system can be analyzed, and the analysis will be happen by considering all these type of factors. Next factor is the size and type of storage facility, means which type of storage facility you are providing of that particular area. Either it is in a, they are doing it is in a basement storage, or they are storing it at their own level in their house also. Attitude of generators and available resources. So these are the very important factors that has been related with the with this hall container system. Because of this hall container system only we'll get idea like this how this hall container system will work after taking all these factor very importantly. So now comes to the next factor, what the route type. Route type is also much important while designing operation for the hall container system. For hall container system, first it is like that it aims to collect maximum amount of solid waste with minimum collection time and efforts. It is determined by trial and error. So and now, but now there is a computerized program for route selection also. With times the operator can gain the enough expertise to perform and determine the route professionally. So this route type is a very important factor while designing this hall container system, because this we should avoid high traffic route, we should avoid high congestion route, and mostly for this type of method highway should be preferred. Or either if this storage is available in the middle of the city, then it is you should be avoided this type of condition, because this will be not aesthetically good. So better to keep this hall container system either a less density population area, or sometimes some outside of the area, or this hall container system route should be basically should be the highways only, not with a narrow road or a narrow or any colony or any municipality type. So this is the this program is route selection is a very important factor while designing the hall container system operation, and with the time the operator can gain the enough expertise to perform and determine the route professionally. So this hall container system, as we know, after some time the person will get idea like how they have to do, or they will get more efficient and they will get more professional in the route designing and performing their daily operation duties. So this route is also a very important factor in this whole container system. Now comes to the vehicle type and vehicle size. Vehicle type and vehicle size is again a very important factor because it depends on the solid waste quantity, quality, land topography, and the status of street and neighborhoods. And crew size is also we can see the crew size because some activities in solid waste management are done manually only, and the crew size is an important to optimize productivity, and it depends on the collection machines, techniques, and tools. So this crew size, vehicles type, all are connected with each other while designing this whole container system. And for crew size, it is important to take one or two members because everything cannot be mechanized. Some manual things should be done during this solid waste management. Then you can achieve your whole goal, because while handling of the waste, while depositing the waste to the landfill site, there will be some problems are there, so a crew member is very important to handle or to see the whole operation. Now the length and number of shifts, which it aims to get full loads in a collection vehicle. Such arrangements must be flexible and assessed from time to time. And shift productivity should be taken in consideration when determining the demand for extra shift. So this lengths, number of shift, crew member, the time taken by the person, and size of the vehicles, all are very important points while designing a whole container system. Size of vehicle, size of vehicle, crew members, length, and number of shifts. All these factors. Next is the route type, and next is basically highway route should be followed. Highway route should be followed. So these are the different factors that has been very important while designing this whole container system, because this whole container system is depends on every factor, because while taking the waste from one place to another place, all these things matters. It needs some labors also, it needs some vehicle side should also be big, or vehicle side should be according to the waste generation of that particular place. Like if less waste is there, then vehicle is of that much size. If it is more waste is there, then vehicle is of that much size. So the size of vehicle should be accordingly to the waste production site. Next is the route type, and highway route should be followed while taking the waste for the hauling system. Street cleansing is again a very important factor that has been related with this whole container system. Actually, what happened, street waste generally arises from public behavior like littering in the waste, but sometimes this waste also arises from failure or inadequacy of waste collection service that leads to generator to which leads to generator to dispose of their waste in the streets. So this waste also arises from failure, inadequacy of waste collection services, which leads to generator to dispose of their waste in the streets. So this street cleansing is again an important factor while designing this whole container system, because now as we know that street is generally dirtier because of the ill behavior of the public, but sometimes during the this waste collection, waste disposal method, due to failure in their service, some waste will be falling on the road, or this will be generated towards the dispose of their waste in the street. Now we'll discuss one example. We'll discuss one problem statement related with the collection of this waste. So first of all, we have to consider a residential building that is going to determine the number of solid waste containers that are required if the daily waste generation is half kg per capita. So we have to calculate how much waste, solid waste container is important for to generate for that place. If the waste generation is half kg per capita, and there are 22 families in that building with average 4 person in a family. So what happened if the average solid waste density is 175 kg per meter cube and the container to be collected by municipality twice a week. So already it is given like 88%, 4% is there, 22 family is there. Okay, 22 family is there, and on an average 4 members are there in a family. Okay, it is already given, and a person is generating 1 by 2 kg of waste. So the and 22 families are living in that building, and the average solid waste density is 175 kg, 175 kg per meter cube, and the container to be collected by, and the container will come twice a week. So first of all, number of persons like 22 into 4, because 22 family, each family having approx of 4 members, so 88%, 88% are there. Waste generation capacity is 1.2 into 88 is equal to 105.6 kg per day. Okay, now the volume of solid waste. So the volume of solid waste is equal to 105.6 divided by 175, as the density has been already given. So it is like a zero point 0.6 meter cube per week. Okay, now comes to the waste will be collected twice a year. So if waste will be total waste volume for 1 week, for 1 week how much waste volume is there? So zero point 0.6 is the density into 7 days is equal to 4.2 meter cube per week. This is the total volume. Next is the waste will be collected twice a week. If the waste will be collected twice a week, then 4.2 divided by 2 is equal to 2.1. Then the number of required waste container, if the container volume is 1 meter cube, 1 meter cube, if the container volume is, then it requires 3 container for collection of waste. So this problem has calculated how much container is required if the waste collection by the municipality is twice a week and 22 families are there, and 22 families, 4 members in each family, 4 members are there. So for this type of waste collection system, we need 3 container system. If the municipality will install 3 container to that particular area, then the waste collection will be okay, then it will be sufficient for that place. Now comes to the next example, where what we have to do, where it is like we have to determine the number of required collection vehicle if 8250 household must be served once per a week. Means this type 8250 persons are there, and the waste collection will be twice a week. The truck collects the waste in 4 days a week. It is collecting 4 days a week. Then the truck needs 1.4 minute to serve a household, and the working shift is 5 hour, and the truck works only one shift. So what will happen? Total collection time per week is equal to, total collection time means what? Total time involved in the collection. Total time collection is equal to 1.4 minute per house. Per house, it will spend 1.4 minute, nearly 2 minutes of it, into 8250, as it is already given like that 8250 persons are there. So it equals to 11,550 minutes, means 192.5 hours. So the total hour that every truck can perform per week is 4 days per week into 5 hours per day. Then it equals to 20 hours, and if we'll divide 192.5 hours with 20 hours, then is equal to 9.6 truck. Then approximately it needs 9 or 10 truck. So if a household of 8,000 household people are there, and the truck collects waste in every 4 days, then the truck need 1.4 minute to serve a household, and the working shift is 5 hours, then the truck works only one shift, so it needs 9.6 trucks to collect all the waste from this household. So this numerical is there, that is to collect how much truck how many trucks is required to collect this much of solid waste. And for this question, one another solution is there. This solution is like total working hour per truck is equal to 5 hours into 60 minute per hour, so is equal to 300 minutes. So the number of customer is equal to 300 upon 1.4 is equal to 214.2 customer per day per week. So 412.2 into 4 is equal to 857.1, and total truck required is equal to 8250 household divided by 857.1 is equal to 9.6 truck. So in this way also you can solve this numerical. So this type of question will be there while designing one municipality. How much truck is important to needed to collect waste? How much container is required to install at that place? Next we will discuss some numericals on this hall container system and conventional method and exchange container system. By this method we can compare which one is sufficient and which is important. So this example is all about the amount of how much truck is needed to collect this much of solid waste in a whole operation. How many trucks needed, how much containers should be installed, and this type of numericals will come while designing an operation, while designing a integrated municipal solid waste management part of a city. So now this was all about this lecture. So from now I conclude this lecture with this numericals. In this lecture I have discussed about the hall container system, and I have discussed some problem statement related with the hall container system, like how we can calculate which amount of how many trucks is required to take this much of solid waste, how we need some amount of person to take the solid waste from any particular area. So this lecture is all about hall container system. In next class I will discuss the hall container system exchange mode and conventional mode, like which mode is better, and we'll compare both type of mode. So if you have any queries, if you have any question regarding this video lecture, you can write in the comment box, or you can directly mail me on the given mail id, that is shikha.pandey@gmail.com. So thank you for today's lecture.
Like, share and subscribe. Hit the bell icon for more updates.